Thank you for joining me. This is Dr. Grace Estrada. This is Psych 18 Research Methods. Today we're going to talk about Chapter 2, the scientific method. Start with this because it's very foundational to everything we're going to be learning. So we'll look at the general model of scientific research in psychology, talk about some common sources of research questions, identify different types of research questions, distinguish the differences between theories and hypotheses, identify different types of variables, look at different definitions, conceptual and operational, and discuss validity. At the end, I will also show you how to access our peer-reviewed journals, which are very important for your study, for your proposal at the end of the semester. So in terms of the model of scientific research, there are several steps that we usually go through. First of all, it usually starts with informal observations of practical problems. For example, if you're at a park and you see that more children are using the slide rather than the swings, you might wonder, what is it about the slide that kids are more interested in it? So a lot of times what we're interested in happens because we observe it frequently and we want to know more about it. So then you come up with the research question. After you come up with the research question, and this is the process we're going to go through, you want to make sure it's original. Every type of research costs money and resources, right? So people do not want to fund research when the question's already been looked at a certain way. So we want to make sure that the research question is original. How do we do that? We look at the research literature. So we go through, we have an idea in our mind. Why do kids like slides? Then you go to peer-reviewed literature. What has already been studied about this topic? Then you go back to the research question. A lot of times, the question that you have may have been something that's already been done. So this is why it's important to look at the research literature, because you need to ensure that your study has an element of originality. Otherwise, no one is going to waste their time funding it or even, their time helping you with it. It's got to be something original. So this part often takes the longest. Once you know the topic that you're interested in and you have a question, look at the literature, adjust your question, look at the literature again. And the idea is you look at the existing literature, look at the studies that have already been done, and you want to find a gap in it. What is it that hasn't been looked at in this particular topic? Sometimes it can be a specific population, like maybe the studies that were done were all done on young adults. And there isn't very much known about what happens to adolescents in the same, for the same topic, that kind of idea. So it can be a twist on the participants who you want to include, or it can be another, just a slight variation on whatever the topic is. Maybe if there's a lot of studies already on slides, maybe you want to look at plastic versus metal or something like that, some sort of variation. After you have refined your research question to the point where you know it's original, you looked at the literature, there's nothing on it, then you conduct your study. Remember, an empirical study has to be one that looks at a concept that is falsifiable. That's the key there. So the research question has to be something that's falsifiable. It can't be something like, is there a God? Is there life after death? Those kind of questions are not falsifiable. They are not appropriate for a scientific study. Empirical studies are specifically for questions that we can measure and observe, things that we can support with actual facts and observations. After you get your study, collect your data, you analyze your data, and then you come to your conclusion. Was your hypothesis supported or not supported? And then you go back and start over again. Oftentimes, people in research have a program of study. So they know it's not going to just be one study. It's going to be a series of studies over years and years. And this is, you'll learn as we go on, when you conduct a study, you can't throw everything in the kitchen sink, right? It has to be contained. It has to be narrow and focused. And so given that, you want to add other variables as you go along, and that's why it becomes a program of study. Are there any questions about the model of scientific research? Okay. Finding a research topic. As I mentioned, oftentimes it starts off with informal observations, things that we just see in our daily lives, something that happens so frequently that we just wonder about it and, want to know more. So usually that would be like basic research if they're informal observations. Then there are practical problems. So let's say you're really interested in solving something. Okay, let's go back to that example of the kids in the park. Maybe somebody in City Hall is saying, kids aren't really using this equipment enough. I think we should get rid of the ones that they don't use. But for you yourself, you love slides and you think that all parks should have slides. So the practical problem is, how do we increase the use of slides among children? So that goes from being a basic question of why do kids like it to a practical problem of how do we increase its use? So this is an example of how you can have one topic and take it from a basic research approach to an applied research approach. So informal observations, usually that would be something where you want to do basic research on it, but practical problems, that's where you would have applied research. And as I mentioned before, you look at previous research, what has already been done. Again, it is so important to be original. And I mentioned to you the difference between basic research and applied research. Basic research is simply conducted to add more to the knowledge base, to get a greater understanding of the human condition. Applied research, on the other hand, those are studies conducted to solve a practical problem. Any questions about this? All right. Research questions. There are general types of research questions that people usually come up with. So one would be to describe new phenomena. For example, when COVID happens, like, what on earth is this, right? So when we do look at describing new phenomenon, we're trying to identify characteristics. We're trying to identify frequency. How often is it happening? And intensity, to what extent is this happening? Another type of research question might be to describe the relationships between phenomena and other variables. So once you know the variables involved in a specific phenomenon, now we want to know, how do they relate to each other? Are there systematic patterns that we can find that help us understand this phenomenon more? So a lot of times we'll look at context. Is it happening in only one specific context? Does it only happen at daycare? Does it happen to people who go to the malls, or does it happen in homes? What's going on here? And you want to look at population. Who are the people being affected by this phenomenon? Remember, with COVID, we found out it was mostly young children and the elderly, right? They were the vulnerable populations. And finally, you want to explain the cause of the phenomena. So this is very much hierarchical, right? Start off with plain description, just what is involved. Then you find out relationships, right? You know what's involved. Now, how are they interacting with each other? Then when you have a good sense of that, maybe now you can explain what's going on with phenomena and predict who is going to be affected in the future. Last part, I should have had it here, number 5, is control. How do you mitigate this phenomenon that's happening? And so when you consider your research questions, the topics that you're interested in, if it's something that's been around for a long time, I would say you should not be describing the phenomenon, right? It should be something, move on to the next level, which are relationships between phenomena and other variables. That one can be a multitude of different variables. It's like the example I gave in class was sort of anxiety, okay? You understand what the characteristics are. You can talk about the physiological components to anxiety, maybe the emotional component. Now let's look at what are triggers to anxiety, and that could be a multitude of different variables. And it could be in specific contexts. It could be specific populations that experience this. So this is where you can get really interesting. It's where you can get very creative as well. So just keep in mind when you're thinking about your research questions and your topics, if it is a topic that's already fairly well established, it's been there, you want to look at levels 2, 3, and 4, describe, explain, and predict. That would be much more interesting. Any questions about the types of research questions? All right, quality of research questions. There are really two criteria for quality. One is interestingness, and the other is feasibility. When we talk about interestingness, that means you should not have a research question that is a yes or no answer. That's not interesting, right? You want to have a research question that does not have a clear-cut answer. That's why you have to do research to answer it. So as I mentioned, you want to look for a gap in the existing literature. And you want to also think about the practical implications. How is it going to help? Who is affected by this phenomenon? How can this research help us with those people or maybe mitigate the problem that we see? The other part is feasibility. Remember, follow the money, right? Everything costs money. So you could have a fantastic research proposal, but if it costs $20 million to conduct, it's not going to happen. So you need to think about the time it would take. You know, in developmental psychology, which is my level, my area of expertise, the gold standard is a longitudinal study, you know, because you have this group of people and you study them over time. Those are exceedingly expensive, very, very expensive. And, you know, who has the time to spend 30 years waiting for people to grow up, right? So that's why, I mean, you need to consider the time it would take to conduct a study and the cost. When we talk about cost, we're talking about equipment, materials, participants, and even the researchers. Researchers and research assistants are paid for their time. So when you have a research question, those are the criteria you need to think about. Is it interesting? Does it affect a lot of people? Is it something that's prevalent, right? So relevance, is it something that will affect many people? Prevalence, right? Is it happening quite often, right? And then you think about the cost as well. Is it feasible? So those are the two criteria that we need to think about for research questions. Any questions about this? Okay, so as I mentioned, in this class, it's unusual among all psychology classes because we do not talk about theories. But you need to know what a theory is because you're going to use theories as a framework. So remember, a theory is a coherent explanation. It's really based on ideas, assumptions, generalizations, observations that interpret and illuminate a lot of observations that you see. So there's a basis, there's a foundation for the theory. Okay, it's a framework. So when you have this explanation, right, it goes beyond one particular situation, you're going higher up. It's the kind of a meta level where you're trying to explain many different situations. So that is why it's useful as a framework. The framework explains patterns and problems that you see. It's good also for observations. It's a way of kind of grouping observations and making meaning of those observations. As I mentioned, is kind of that organization. And so when the reason a theory is important in research is usually a researcher will identify a specific theory or even a couple of theories that help provide the lens through which they're going to collect and analyze the data. If you do not have a theory, a framework, it makes it much harder to determine if it's being supported or not. So oftentimes, the research is being used to test a theory. You create hypotheses to determine whether that theory was supported or not with the data that you collected. And so this is why in this class, we don't talk about specific theories per se. The idea is that, you know, you have taken Psych 1, which gave you many different theories, many different aspects of psychology, and that will give you that foundation to think about maybe different theories that you would like to test in your research. So what purpose do theories serve? As I mentioned, you get to produce hypotheses. It offers practical guidance for the type of data that you want to collect, and then helps you generate discoveries. There is no single theory that explains everything about humans. And this is why psychology is actually interesting. We have many, many different theories to try to explain different aspects of human psychology. One of the most common, for example, is Maslow's hierarchy of human needs. So in this theory, Maslow states that before you can go meet the needs of higher levels, you have to meet the most basic ones first. So most basic needs are physiological needs. You have to have food, water, warmth, rest. Once you have that, then you can think about safety and security. Once you have your basic needs met, then you can move on to meeting psychological needs, which include belongingness and esteem. So at this college, we actually really believe in this. This is why we provide basic needs services. We understand that it's really hard to study if your stomach is grumbling, right? If you don't feel safe, if you don't feel comfortable in your classes, how are you going to ask questions? So this is a theory, a framework of looking at the world and looking at the way that people behave in the world, and it predicts certain behaviors. So somebody who's looking at this theory might say, I have a hypothesis that actually basic needs don't need to be met before you can look at intellectual needs, and then they conduct a study. But that's sort of the idea. You look at a theory, it gives you a framework of understanding what's happening with humans, and then you come up with hypotheses to test aspects of the theory. And we'll talk about hypotheses next. All right. When we talk about a hypothesis, there are 3 components you should include. It should be testable. As I mentioned, your empirical question needs to be something falsifiable. Is it supported? Is it not supported? You cannot test if there is life after death, right? You can test if towards the end of life, is there an extra burst of consciousness? That's testable. It's falsifiable. A hypothesis should also be logical. It should draw logically from the theory or framework that you're using, and it should be phrased in a way that is positive. So it would be, the reason we want to do this is we want to say, is there a sudden burst of consciousness? That's a positive framing, rather than, is there no consciousness, no burst of consciousness that happens when somebody is close to death? So when you phrase a hypothesis in a logical, positive way, it's much easier for people to understand. So I want to clarify, we talked about these 2 terms, theories and hypotheses, and sometimes people get them mixed up. When it is a theory, it is broad, right? It's kind of a higher level. The idea of a theory is it can apply to many different studies, many different situations, contexts, and populations. It's a general explanation, right? It's an explanation of unobservable phenomena as well as observed behavior. You can have theories about unobservable phenomena like feelings, right? No one could really read your mind. Nobody knows how you feel unless you behave in a certain way that expresses those feelings, but it can still be, there are many theories about emotions. A hypothesis, on the other hand, is specific. It is specific to a study's context and sample participants, right? A hypothesis is a prediction that is drawn. It is based on the theory and or observations. So if you're trying to decide, if I give you an example and I say, is this a theory or a hypothesis? If it sounds like it's very general and can be applied to many different situations, chances are it's a theory. On the other hand, if it's something specific, people who drink 2 cups of coffee or more are more likely to finish reading a 50-page novel than those who do not. That is a hypothesis. It's specific. It talks about something that's observable and measurable. That helps you figure out that it's a hypothesis. I'm not talking about everybody. I'm just saying people drink 2 cups of coffee or more, right? That's a very specific group of people I'm talking about. So when you're trying to decide between theory and hypothesis, that's one way to consider it. Any questions? Okay, means you all understand that. All right, elements of a research study. You're going to hear these terms and you should understand them. Okay, variables. When we talk about variables, that's what you want to study, and it's called variable because these are elements that change, right? Variables fall under certain scales of measurement. We're going to talk more about this, I believe, in chapter 4. But there are 4 scales of measurement, and they depend on the type of variables. So there are qualitative variables, which are not, they don't have to do with numbers. That's why it's called qualitative. So nominal and ordinal are the scales of measurement that are associated with qualitative variables. And then quantitative variables having to do with numbers are on an interval or ratio scale. If you don't understand that right now, don't worry, we are going to cover it in a later chapter. So variables are things that change. Oftentimes that is what we're going to be looking at in a research study. Another 2 more important terms to know. There's the conceptual definition of a phenomenon, meaning what is the theory? This is why you look at previous research that's behind it. What's the conceptual definition of anxiety? All right, so this is a condition in which people have this sense of dread or worry, and so you have these different definitions, and you would cite it, right? You're getting this definition from previous research, from experts. You would have a citation for this conceptual definition. This is the phenomenon you're looking at. Then there is the operational definition. The operational definition is how you, in your study, are going to look at this phenomenon, a specific conception of it. It has to be observable, specific, and measurable. So anxiety is a feeling, right? It's how do you measure somebody's level of anxiety? Well, you could do a survey and do a self-report on how they're feeling at this moment in time. You could say, oh, I'm going to hook them up to some devices. And if their heart rate goes over, 80 or something like that, I'm going to say they're starting to feel anxious. So something like that, something where it is specific, observable, and measurable, that's your operational definition. You need both in a research study. So you're going to have to define the concept, define the phenomenon using literature, expertise, those kind of definitions. And then you're going to say, this, in my study, this is how I am going to study this phenomenon. This is how I'm going to define it. This is how I know this is happening to my participants. That's the operational definition. So you should know what a conceptual definition is, an operational definition. Population versus sample. Who are you studying? It is impossible to get the entire population. So in research, we are always looking at samples. Though that is a subgroup of the population, and you would specify who it is that you're looking at. So just keep that in mind. You want your results to apply to the general population, but your results are actually based on a sample. And so it's important to have the sample be representative of the population that you're interested in. That's key. So main types of sampling, simple random sampling, that's if you get everybody's name, throw it in a hat, and then you pick one out. That's random sampling. Convenience sampling is another type of sampling where you essentially, you're not getting everybody in the population, you're just getting a subgroup that's easy to access, and that's why it's called convenience sampling. And there are many other methods. We're going to talk about that in chapter 7 when we get to surveys. Any questions about these definitions? Okay. Types of research approaches. After midterm 1, we're going to dive right into research approaches and research designs. The very first one we're going to talk about are experiments, because there's a specific definition for what makes a study an experiment. So experiments, remember, are the only type of research that can determine cause. It's the only type of research that has manipulation of the independent variable, right? You manipulate the independent variable, which is what you believe will cause, an effect. The dependent variable is what you measure afterwards. So in an experiment, you have the independent variable that you believe is going to influence an outcome in the dependent variable. So you manipulate the independent variable, you measure the dependent variable. Extraneous variables are those that exist but are not actually actively being studied in your research. Those are things, they could be when we're talking about people, it could be eye color, it could be hair color. Extraneous variables should not impact your results at all. However, there are confounding variables, which are variables that are extraneous and systematically change with the dependent variable. And so it becomes a confound because you don't know if it's the independent variables that cause the change or if it's a confound. That's why it's called a confound. So you want to make sure as a researcher, you consider any possible extraneous variables that can influence the dependent variable. Something really important to think about. So experimental research is gold standard. We start off with that. Everything else is non-experimental. So experiments are used to determine cause. They're very expensive because you have to exert a lot of control in the experiments. Other types of research designs fall under non-experimental. We use non-experiments to describe, explain, and predict what, phenomena are happening. So there is room for both types of approaches. They have value. Not everything needs to be tested by an experiment. And that's why we have many different types of non-experimental approaches as well. Any questions about types of research approach? Okay, so all of this, I'm hoping you're thinking about your topic that you like, and hopefully something is kind of triggering interest in you about how you might want to approach it. You have plenty of time, but I do want you to start thinking about your topic and your research question, because that will help as we go through the class, help you kind of pull together the proposal you want to do. Other things you should consider: context. Do you want to conduct your study in a laboratory, or would you want to do it in the field? So if you want to observe people in their natural environment, you would do it on the field, quote unquote field, at the school or something, that kids in a school, kids in a park, that's considered a field study. You do a laboratory study if control is very important, where you want to make sure that everybody is, in the same kind of environment and circumstances. You would bring them into a lab. So there are non-experimental studies, such as observations, that would happen in a lab. And there are experimental studies that you might want to do in the field. It depends on how you want to conduct your research. Validity is a word that you are going to hear over and over and over again, all the way to the end of this class. It is sort of the idea of, are you measuring what you say you're measuring? That's what validity is. So valid claims are solid claims. It's an indication of how sound your research is. There are different types of validity. Internal validity has to do with the structure of your research. That's why it's called internal, right? The degree to which you can confidently say that it is this, independent variable that caused the change in the dependent variable. So experiments have the highest level of internal validity because we have that control and manipulation. Non-experimental studies don't have that, but we still want to see to what extent is the research valid. External validity has to do with the results. How well can those results that you found from this sample of people actually apply to people outside of the study, to the general population? External validity is also known as generalizability. How do we take these results and have them apply to others? So internal validity is the integrity of the structure of your research design. External validity has to do with the results. It's the generalizability of what you found. And there are numerous other validities that we're going to talk about in chapter 4. Any questions so far? All right, so steps to research, recapping. One, look at the research literature. So this is after you've come up with this topic that you're interested in. Look at the research literature, decide on a research question of interest, incorporate the theory, determine the variables of interest. So oftentimes you're going to look at the theory, and the theory will guide you to what variables you should be looking at. Develop your hypothesis, make a prediction, select an approach, choose a research design. So when I say select an approach, it's sort of, are you, do you want this to be qualitative or quantitative? Do you want research design? Do you want this to be experimental, not experimental? All of these are going to be drawn from your research question. So remember, we talked about this elements of the research study. Here is sort of helps, this table kind of will help you learn these definitions, right? Research question is a description of the broad topic of study. For example, are there differences among groups in terms of cell phone use while driving, right? Very general. Your hypothesis is a tentative idea or question. Usually it's going to be kind of drawn from something you want to test in the theory. Do males and females differ in their use of cell phones while driving? And then finally, you have your prediction. It's a deliberate guess at the answer to the hypothesis. For example, females are more likely to use a cell phone while driving. So this is just like a little table to help you differentiate between a research question, a hypothesis, and a prediction. This is just a recap. So when we have this model of scientific research, right, your introduction is going to capture the informal observations you've made, your research question, and the research literature. And I just saw a typo, sorry about that. Your methods and procedure are going to be captured in your empirical study. And in the study, the results are what present the data analysis that you've done, and then you have the conclusion or discussion. So when you have the scientific method, this is how it breaks down into the study. Any questions about this one? All right, so types of research methods that we will look at: observations, qualitative, and experiments. So observations are a type of qualitative study. Naturalistic observations happen in the field. So you're not taking people into a lab, right? You're actually watching them in context where they would normally be. A laboratory observation is one in which it's controlled, and you want to make sure that there aren't any extraneous variables that are going to muddy your data, right? And a case history is also a type of observation. Oftentimes this is in clinical situations, and we usually only use case histories when it's a very unusual phenomenon. So a rarely occurring neuroses or something like that. So we usually don't use case histories unless somebody's discovered a very unusual problem. Surveys can be qualitative as well. Surveys are wide-reaching. I'm sure many of you, after you purchase something online, you'll get a survey. So we're very used to surveys. And there's a specific way that you should be forming the questions. We'll talk about that in chapter 7. Clinical interviews are also very frequently occurring. When you're talking about interviews or focus groups and looking at what people are saying, the words they're saying, then it's qualitative. So qualitative studies tend to focus more on interpretation of what people are saying. So in quantitative studies, it's actually easier to collect the data. You can have a lot of many different people, a lot of participants in a quantitative study, have the survey, and then you do the analysis. Qualitative studies, on the other hand, upfront, it's easier in the sense that you just come up with questions. What's harder is the analysis for qualitative studies. And then you have experiments where you have control and experimental groups, manipulate the independent variable. And as I mentioned, experiments are the gold standard when it comes to research designs. Okay. So when we start getting into this, you're going to hear these terms of a null hypothesis and alternative hypothesis. The null hypothesis is our conservative approach that we believe that, nothing is the control group is going to be the same as the experimental group. In other words, changing the independent variable will not have an effect. So we're saying it's not going to work. That's not what we want to happen, but it's called the null hypothesis. Think of null as in zero effect. The alternative hypothesis is what we want to happen. This is the hypothesis we want to support, but we need enough data to say, no, we can get the null hypothesis. So the null hypothesis is a statement about the population parameter. We say population parameter and sample statistics. So the numbers, the term that we use for those numbers are different, whether you're talking about the population or whether you're talking about the sample. When we're talking about a sample, it's a statistic. When you're talking about the population, it's called a parameter. A lot of times the null hypothesis is going to include things like equals, not equal to, greater than equal than, or less than equal than. The alternative hypothesis is a statement that contradicts the null hypothesis. It's usually a statement that says what we believe is going to happen. We want to support the alternative hypothesis and reject the null hypothesis. If the data do not support our hypothesis, then we fail to reject the null hypothesis, meaning it didn't work. If you're not clear on what this means, don't worry, we will talk more about it. Analyzing results of research. So these are the main things you can do. You can compare group percentages. You can correlate scores of individuals on two variables. You can compare group means. Those are the main things we do when we're analyzing research. This comes along in chapter 12 and chapter 13, right? How we analyze the data that we get is going to depend on the scale of measurement of the data that we're getting and what kind of data. So that's what we mean. Is it qualitative? Is it quantitative? Is it categorical? What kind of data are we getting? So all of this, as a researcher, you actually have to consider that. It's all going to be based on your research question and the kind of approach you want to take. So descriptive statistics, we're going to talk about this in chapter 12. We'll talk about, central tendency, that's the mean, median, mode. Variability would be standard deviation. So central tendency is a number that really kind of is supposed to capture generally how the participants did overall. Gives you a sense on how they did. An average, the mean, is an example of central tendency. Variability, on the other hand, gives you information on how much your participants varied from each other. What was the change that was occurring among the participants? How wide is that distribution? So both of these are important data points that we need to consider when we are looking at analysis. So describing data, you can have a frequency distribution, right? And this is sort of just gives you a sense on where the numbers look like. So we manipulate the data visually by using pie charts, bar graphs, polygons, histograms. And I'll go over that. So a pie chart, usually that's going to describe the percentage or number of responses. A lot of times we use percentage, so it gives you a proportion, right? This is usually used for a single nominal scale variable. For example, if we were doing a study on how many children were read to at home or not read to, we can easily present this in a pie chart, right? Where you have 80% of children were read to by their parents and 20% were not read to. It's a nice way of just capturing the data. People love pie charts. Another way to do it is a bar chart. You can also, this is for nominal data. And notice that in the bar chart, the two bars do not touch. All you're looking at is frequency. So again, that same data of how many kids were read to and not read to, you can present that in a bar graph as well. So here you can see the frequency on the y-axis and on the x-axis, read to or not read to. Oftentimes you'll see them in different colors. Frequency polygon. Here's an example of a frequency polygon. So instead of using bars, you're going to use lines, little dots to show the different data points. So this is just another way that we visually represent data. The most common, most well-known frequency polygon is a normal distribution, right? This is what's known as a histogram. In the histogram, you see that the bars are touching. That's because you're looking at a continuous line where you want to know from 0 to 2, you're including every number in between there, 0.1, 0.2, 0.3. That's why the lines are touching, right? When we look at this is the normal distribution that we're talking about. We'll talk a lot about the normal distribution in chapter 12 at the end of the class. I just want to give you a sense of different ways that we represent data. So as I mentioned, when we talk about descriptive statistics, we're looking at two main things: measures of central tendency, mean, median, mode, measures of dispersion, range and standard deviation, and variance. Those are things that we look at for descriptive statistics. The idea of descriptive statistics, as it we're trying to capture the main tendency of the sample that we're looking at. So mean, we'll go over this. All of you took stats before you took this class, so none of this should be new, right? Central tendency is how participants scored overall, and it depends on the type of scale of measurement that we're using. So if you're measuring the mean or average, you can only use quantitative variables. Median, on the other hand, you can use any type, ordinal, interval, and ratio scale variables. And if we're talking about mode, it works for all the types of variables. Variability, we're looking at spread, right? Range is just the difference between your highest and lowest scores. Standard deviation is the average deviation or change from scores from the mean. Hopefully all of this sounds familiar to you, right? When we are looking at standard deviation, we want to consider what the value means. If the standard deviation is small, it means the scores are very close to the mean. It means there is very little variability among your participants. If the standard deviation is large, then that means the scores were really, really spread out. So the score of one person could be, 20 points off from another person, for example. If the standard deviation is 0, it means that everyone scored exactly the same. There was no variation whatsoever. So when we think about standard deviation, consider whether it is small or large, because that will give you an idea of how much your participants varied in terms of their data. Correlations. You'll see a lot of this in studies. So, whoops, sorry. We are looking at how data falls when we plot it on the x-axis and the y-axis. If values are going in the same direction, we say it's a positive correlation. That means as x increases, so does y. As x decreases, so does y. That's what we mean by the same direction. On the other hand, if one value goes up and the other value goes down, then we say that's a negative correlation, right? It's going the opposite direction. As x increases, y decreases, or as y increases, x decreases. They're moving in opposite directions. So just remember generally how correlations are working. If we were to look at scatter plots, this is what it would look like. Perfect positive correlation would be a straight line going upwards. Looks like it's going up, right? Modest positive correlation, it's going to be a little more scattered, but still easy to see. And then you have no correlation where it's just scattered all over. There's no systematic pattern. A perfect negative correlation, you can see as the x value goes up, the y value goes down. That's why it's negative. And then there's a modest negative correlation. Nothing in nature is ever perfectly positive or perfectly negative. That's only going to happen, in some sort of simulation. Any questions about correlations? Okay. This is, we talk about all that toward the end in chapter 12. Chapter 13 talks about inferential statistics. It's called inferential statistics because what we're trying to do is look at the results from the sample of people, and we want to infer if those results are also going to be found in the general population. That's why it's called inferential statistics. When we say something is statistically significant, what we're really trying to do is find out what is the probability that these results that we obtained in our sample are also going to be found in the general population. That's what we're trying to infer. And so we'll talk about p-values. P equals or is greater than 0.05 is the usual standard in psychology. And we'll also talk about the use of confidence intervals. So here, p-values are probability values. In APA format, you are supposed to report the exact p-values, or you would say p is less than 0.001. You can never say p equals 0, right? So you want to say less than 0.001, meaning it's very, very low. We want that very, very low p-value because what that means is that there is a very low chance, very low probability that the results we found in the sample only happened by chance. We believe that if we were to conduct the study 100 times in the population, that we are likely to find a similar result. That's really what we're saying. This is an example of a confidence interval. We'll talk about that in chapter 13, but in some of the studies you look at, you might see that referred to. So confidence interval is something in inferential statistics and helps us decide what is the probability that the result we found in this sample also represents what would be found in the population. That's really what the confidence interval is saying. So if you have a 95% confidence interval, it's saying within this range of values, right? You have the lower confidence limit and the upper confidence limit. You are certain that, if you were to conduct it 95 times or 95% of the times, the true value of the population lies within that range. That's really what you're saying with the confidence interval. Okay, so when we talk about comparing group means, we're looking at two different groups. A lot of times what we're doing, we want to know, for instance, many studies like to look at gender differences. Are male identified different from those who are female identified? When we're comparing group means, what we're doing is we're comparing the means of the dependent variable for each group, right? For an example, there was a study Wasson Payne did in 2007, and they were looking at the impact of environmental cues. This is a fun study. I would have loved to be part of it. So what they did is they brought participants into a restaurant. And so one group, they're given chicken wings to eat. I love chicken wings, right? So what they did is they had people eating chicken wings. And then the unbussed table, they just let the pile of wings pile up. Just, the bones. The pile of bones as people are eating, they just left it there on the table. That's an unbussed table. On the other hand, a bus table is when the waiters would come and take away the food. You ever wonder why they do that? A couple of reasons, right? What this study found is that when people saw the bones piling up, they ate less, right? So men on average ate 163.3 grams of wings on an unbussed table, and women ate 207.3 grams of wings. So they're looking at men and women here. But on the bus table, meaning they took away the bones, look how much more the men ate. 264.8 grams when they didn't see the pile of bones adding up. Women ate more too, but not nearly as much as men. The increase wasn't as much with women. So this is an example of where we're comparing the means of two different groups, women and men. This is what we mean by comparing group means. So there are many different types of studies where you could do that. Now, in terms of drawing conclusions, so you have all these data, you have these results. Now you're deciding, are you going to reject the null hypothesis or retain it? Well, there are two possibilities that could happen, okay? Remember, in inferential statistics, you are trying to decide, will the results from your sample be found in the general population? That's the point to inferential statistics. This is what we draw a conclusion because we want to make a statement about the population. So if you think the null hypothesis is true, meaning there is no difference, right? Taking away the bones won't make a difference. If you say that's true, and that is what happens in the population, that, it's not just that sample group of people who ate the wings that would be found, that if you went anywhere outside, that people tend to eat less when you see the pile of food piling up, then, null hypothesis true means that they don't care. So if the null hypothesis is true, then people don't care if they see bones piling up. And so that's their conclusion. They accept the null. If that happens in the regular population, then you've come up with the correct conclusion. So that's in green. You accept the null, that's your conclusion from the statistical analysis. And in the population, it's true, that's the correct conclusion. But what if you rejected the null in your study? You said, actually, people do care when they see this pile of bones popping up. So I'm going to reject the null hypothesis, but in the real population, that's not the truth, then it's what we call a type 1 error, right? So we rejected the null, but the null is not actually happening but the null does happen in the population. That's why it's an error. Now, on the other hand, what if you rejected the null? You said, oh, it's people care about the bones piling up, and in the population, it's true, people did care about bones piling up, then you rejected the null, it's a correct conclusion. On the other hand, if you reject the null and it is true, then that's a type 2 error, right? So sorry, accept the null and it's true, then it's a type 2 error. So follow the, here, accept the null and the null hypothesis is true in the population, right? That's a correct conclusion. If you accept the null and the null hypothesis is false in the population, meaning it is actual bones really do matter, then it's a type 2 error. In a type 2 error, you accept a false null hypothesis. In a type 1 error, you reject a true null hypothesis. We'll talk more about this toward the end of the class, this whole idea of the type 1 and type 2 errors. Just understand that when we come up with the conclusion, it's not enough to say what happened in our sample. We need to know, what we're trying to do is extrapolate and say it's what's being found in the general population. So when we draw conclusions, we always talk about whether or not the hypothesis is supported. We don't talk about proof in psychology. We talk about support, because there could always be another alternative another study that comes up with alternative conclusions. So we talk about this study supported this hypothesis about this theory. So if it's statistically significant, then we'll say the alternative hypothesis is supported. If it's not statistically significant, then the theory is not supported, and we can talk about why. Could be flaws in the study, could be our analysis. There could be a number of reasons why our hypothesis is not supported. So in the scientific method that you all learned in school, right? We talked about the introduction. In your introduction, you have the purpose, you have your lit review, you have your hypothesis. Then you have your methods. Talk about, how the study was conducted, right? That includes the procedure. Then you have your results, and then you come up with your conclusion. So that is your scientific method. Any questions about this? Okay, I do want to talk about finding peer-reviewed articles. So I have these in slides, but if you want, I can also walk you through it live. Okay, so in your single sign-on, you will have an icon that says EVC Library Online Articles. That is what you're going to select. It will take you to the library. When you get to the library part in our website, select online articles, right? So you don't have to go and buy any articles. We have databases to help you that have free peer-reviewed journals. So either select P if you want to go to psychology, or select social sciences. I recommend you select social sciences, which is over here on the right, where it says view databases by subject. So you select that, it'll take you to the databases that are relevant to social sciences. I recommend you start with psych articles first. They're going to have a very wide variety and usually newer articles for you to use. So if you go to psych articles, right, I want you to go to advanced search. Why? Because there are certain options I want you to select. So you go to advanced search, and there's going to be a part that says start year. Remember, I don't want you to use studies that are more than 5 years old. So your start year, I would say go with 2020. You can go as 2019 since it's 2024, but 2020 is much safer. So your start year should ensure you don't get articles more than 5 years old. You also want to exclude book reviews and non-article content. It's just going to muddy up your results. So make sure you get rid of those parts. So you're excluding unnecessary entries. Then you go to the keywords, right? So for example, I put in learning styles. If you have multiple keywords, that's fine. Then you click on search. So there are your search results. And if you see PDF full text, then you have the entire article right there, and you can go look and see if it's relevant or not. It depends on how many results you're going to come up with. It says there are 50. That's a pretty good number. Now, something to keep in mind, right? So I had these keywords and then I have these results. You want to take a look at the results that you got so you can identify the gap in the literature. What has already been studied, right? That's the whole point. If you come up with way too many studies, you might want to refine it. And so there's a way on the left-hand side there, it says refine results, and you can actually narrow down what you get. And there are even some video results that pop up. So it's a really great resource for all of you in terms of when we start looking at journal articles and needing to get that. Are there any questions? I'm going to stop this recording.